I mean, I like Mondays, but yeah.
I like waking up tired. Like, what's going on?
All right. So, what we're going to be doing today is we are starting Unit 6. This is one of my more favorite units. I will say it's different than what we've been doing because there is absolutely no interpretation this unit. Literally, all the directions are going to say integrate this. The hard part is I'm going to teach you kind of 5 different ways to integrate. And you're going to have to make a choice of which method to use. I think that's really exciting because I think making choices is one of the greatest parts of math and having to make correct choices as we go. You guys will love this. You'll like this. You'll probably hate that. This will be fine. Today is going to be a little bit weird. We're going to talk about some weird functions called transcendental functions. Those are ones like sine, cosine, e, natural log, stuff like that, arctrig. So that's kind of the outline of what we're going to do. Now this test, we may take this this is the last week of the quarter right now. We may be taking it that week, but I'm going to tell you this is not going on second quarter. The round 2 right now is getting pushed pretty darn close to the edge of the quarter, and I hate doing that where we take a test right at the edge of the quarter. Also, we have enough grades this quarter to already fill out the amount of points I need. I'll need this test for next quarter. So if it snows, everything's just going to keep getting pushed back. We're not rushing at all. So just keeping that in mind. I have new problem sets for you today, but this is kind of our outline.
Will the problem set be on this quarter?
That's a good question. Probably depends on snow. So we'll see. All right. So let me pass out notes today. They are no staple notes, but they will take a slightly long time. Yeah, we will have some more notes checks. I'll probably cut those off kind of the week before the quarter ends. You have time. No, I don't know. It works. Oh, last kind of announcement.
Oh, really?
I did de-hoard all of my papers. I apologize. I was doing serious paper hoarding. If you picked up your Unit 4 test, I know some of the people were very interested in reassessing that test. Again, you're eligible to reassess if you are less than 80% currently, and you can reassess up to 80%. The way you do that reassessment is you essentially make test corrections. You can either do that with me or on your own. Once I see that those are completed, and kind of, essentially I just need to know that you're going to do better on the next test. You'll let me know, and I can give you, it will be a new version of the test. It will be slightly different, so the directions will probably look very similar, but some of the numbers and graphs will be different. If you're interested in doing that, my goal is to get all of those done by Friday of next week. So just if you're interested in that process, make sure you're talking to me and getting that done by Friday. Any questions on that, guy? Yeah. Really big grades? No, we're kind of done with really big grades. All right. We are going to front load these notes a little bit. So I'm going to get through the rules at the top and hopefully 3 examples. We'll take a break and then we'll have 3 more questions. That doesn't sound like a lot of questions, but a lot of these are a little bit harder than I forgot, you guys. Has anyone been touching the board now? No. I think they're getting just auctioned off.
Especially when everyone's waiting. It feels so good. $100 for a flat. 16-inch flat screen TV. Not bad.
Okay, they're actually always
We can write on it later. All right, I will say, why are we looking at shoes right now? No one's taking pictures. I swear, we were doing an activity with markers yesterday in my AB class, and I look up and like 8 of them, and I only have 16 of them are on their phones.
It was a long break. Does anyone know what theorem it is?
mean value theorem.
Did you read it or did you know? I'm saying the middle one, they did a good job on theirs. It looks very neat and nice. The middle one, Sadie and Satya's, I liked a lot. What? Sadie what? Sadie Lee? Lay? I don't know how she pronounces it. All right. What are you doing? All right, we ready to go? There are 2 typos on this set of notes. See if you can find them. There are ones that you can find. All right, so I'm going to preface today with saying, though these notes contain a lot of good information and a lot of good skills, the actual integrals we're going to be doing, there will not be very many of these, 1 on our Unit 6 test or 2 on the AP test in general. There are 3 rules on this page that are more important than other ones. You can probably predict what 2 of them are right now because we've done those ones before. The other one is going to be this one. The rest of these can be pretty fuzzy. Surprisingly enough, that one's going to come up a lot in the section that was called improper integrals because that function that's going to pop out of that integral does a lot of cool things as you go to infinity. So let's see if we can remember some of these. What is the integral of e to the x?
E to the x.
Anything else?
C.
Plus c. All right. The other important one, does anyone remember what that one is? There are bars and natural log absolute value of x. Yes, you have to put the absolute value bars. You're going to notice how important this integral is today because we're going to use it probably 3 or 4 times today in the 6 problems that we're doing. So again, a good way to remember this one, if you kind of forget it while you're integrating, a lot of the time we transfer these into negative exponents. If you try to do that with this question, you're going to add 1 and you're going to try to divide by 0, which, let me remind you, is not legal in mathematics. So if you get in that situation, ponder a natural log. But probably by the end of today, you're going to recognize when you need to do that. A reminder that's only when the x or the u, if you have it, is to the first power on the bottom. Otherwise, that negative exponent will work. All right, anyone see a typo yet? Yeah, this should have a dx in it. I'm going to say for all of these, I'm just going to make a little note up here. A is a constant, so a number. So if I'm doing a to the x, this one should look a lot like e to the x. I'm going to remind you, or maybe you'll remind me if you're feeling fancy. Does anyone remember how to take a derivative of something like this, a to the x? Something like 2 to the x or 3 to the x? All right, there is an a to the x, but there is something here. There is a natural log of the base. So I like to think of that as kind of like a correction factor for not having the right base being e. E plays really well with calculus, something like 2 or 3 or 4 as the base does not. So, question to you, because you're good at pattern making. If I multiplied for the derivative, that natural log of a, what do you think I'll do in the integral? Since they're kind of opposites. Divide. So when I do this, I'm going to do 1 over natural log of a times a to the x. Again, the level of importance of that type of integral or derivative, to be fair, is probably at most 1 multiple choice question on the AP test. Probably all of these rules together, minus the 3 I highlighted, you'll have 1 multiple choice from like all of these rules. So just keep that in mind. All right, let's move on to everyone's favorite, inverse trig. Anyone remember the two inverse trig functions we used? There were two that we kind of talked about. They had arc in front of them. Arc sine and arc tangent. Does anyone remember which one looks like which one? Good. All right. So this guy's arc tangent. This top guy's arc sine. A little bit different though. When we took the derivatives of these, we did some chain rules. So the a in our derivatives was always like a 1, and then we chain ruled at the end. This is a little bit weirder. I am not going to prove to you why these are true because 1, I don't think you care. And 2, it's not really worth the time and effort. You could take a derivative to see why it's true, but we're just going to go with this. So this is arc sine of u over a plus c. I always remember arc sine because it has the square root on the bottom. It's going to have the number first every single time because the a squared. The subtraction makes it so that that is the order of the entire time. Now, arc tangent, because tangent's derivative is a little more complicated. It's secant squared versus just being like cosine for sine. This is going to have a 1 over a out front. Arc tangent of u over a plus. We're going to practice with these ones quite a bit today because they're the more important ones of the new stuff we're going to be learning today. There's a lot of patterns in this though, so we'll kind of keep that in mind. But mostly what we're going to be doing is identifying what u and what a are. All right, the last 4 are integrals of trig functions we haven't done yet. I'm going to show you how to do the tangent one and the secant one. I've only written room for the tangent one because the secant one, if you remember how to find the formula, it's about as easy as just memorizing the formula. I'm going to show you why it is the way it is, but in the end, if you want to get a 4 or 5 on the AP test, you'll probably just memorize these. If you want to get like a 2, you do you. So, anyone remember from pre-cal a fraction that is equivalent to tangent? Whatever cotangent would work, but I want an easier one. There we go. It's after winter break. We rusty. All right. How would you do the integral to this question? Probably Yusuf. Yeah. If I make a real emphasis on you, I'm trying to tell you something. What would you make as the u for Yusuf? Good. When in doubt, denominator it out. That really rolls off the tongue. Let's remember how to do some Yusuf because yeah. The dx will pop up when I take the derivative. So speaking of derivatives, what is du, the derivative of u? By the end of this unit, you guys are going to be saying, Yusuf is the easiest thing ever. All right, I don't have that negative in front of the sign in my integral. I just have sine x dx. So I'm gonna be creative and do this. Yeah, I'm going to in a second. So like Brandon's saying, I'm going to take this negative and put it out front like I have with a lot of my fractions or numbers for my du. My integral will be there. I'm going to keep my du at the back end. In my fraction, we chose cosine to be u, so that'll be on the bottom. What can I put on the top? Ooh, a 1. Good idea. Ooh, this looks super familiar. How do I integrate 1 over u? Natural log. So the negative will stay. We got natural log, like Mia reminded us, we need the absolute value bars. I don't care how you remember it, as long as you do. That's like the thing we're learning next class is called integration by parts. But one year my students started calling it OOV-VADOO because that's like the formula. And then they remembered it better. So then I just let them call it that. It sounds stupid though. Yeah, it does. So I was like, please don't go to your college professors and be like, is this OOV-VADOO? All right, I'm gonna plug my u back in as I write down this. So this is negative natural log cosine x plus c. So is this my favorite integral? But no, it's just not. But if you forget it, this is a decent way to remember how to derive that, because most of us will remember by the time we get to the AP test that tangent is sine over cosine. The secant one, on the other hand, I'm going to show you how to get it. I did not leave you room to write this down. You can if you really want to. I want to show you why it is the way it is, but you're not going to, if you remember how to like derive the formula, you're going to remember the integral anyway. So if you want to, just kind of hang out, watch, make sure I'm doing everything that's legal. So I'm going to show you why it is the way it is, and then we're going to move on from there. So over here, I am going to multiply by a very fancy form of 1. So again, don't feel like you need to write this down. What I would like you to do is confirm that the big thing I'm multiplying by is indeed equivalent to 1. If you're feeling very feisty, try to think of why the heck I'm multiplying by this thing. I'm focusing really hard so I don't drop the C in secant x. All right. Is that 1? All right. Anyone know why yet? All right. I'm going to distribute on the top. I don't have to on the bottom, remember, because it's over 1. So multiplying across the top, across the bottom. Secant times secant is secant squared. Secant times tangent, I'm just going to write it like that. On the bottom, I still have secant x tangent x. Thoughts on what you would do next? Let me rephrase. Thoughts about what you would do next? Oh, what? What would you say is you? Yeah, denominator. Let's try. All right. Let's see who didn't get super rusty over break. Who knows their trig derivatives? What is the derivative of secant x? What is the derivative of tangent x? So you're saying secant x, tangent x plus secant squared x? Like the entire numerator? Helpful. So that entire numerator is just my du. The entire denominator is just my u. Or I could write this like 1 over u du. Yeah, what does this integrate into? Agreed. So I also don't want you to think I'm very clever. How did I know to do that? That I saw that in a textbook it works. So I'm not like clever enough to come up with this. So the end result is you get the integral natural log absolute value of secant x plus tangent x. So when I'm saying don't write this down, because if you knew to multiply by that fraction, you would know the integral in general. So this is one where it's like you're going to memorize this if you would like to know this for a test or the AP. The integrals of cotangent and cosecant are very similar. So cotangent you could do just like tangent, but you'd have cosine over sine. Since your u would be sine with a derivative of positive cosine, this would be positive natural log of cosine over sine of x. So you could do that one very similarly. As I go get the water from the back of the room, I would like you to use your pattern-making brain. Don't try to actually do math, but I want you to think about the patterns of tricks. There's a lot of them. Try to predict what would go right here.
I think it's something to do with tangent. Yeah, for sure. Cosecant goes into cotangent. You want to do cotangent. Yeah.
Anyone got any ideas at all? All right, I like the idea of cosecant plus cotangent. Okay. I like the idea of natural log. Anything else? Plus C, anything else? It'll be negative. All of the ones that have C's, this is still true. All of the ones that have C's still have a negative sign. So if you are interested, I think a lot of these integrals are what I would consider like 4 or 5 barrier questions on the AP test. Like someone who's going to get a 5 on the AP test will probably have these memorized by the time they get to the AP test. And this is a kind of a freebie question because if you don't know it, you're not going to get it right unless you guess right. So if you know these, that's great. There's a ton of patterns though. So if you're studying them, study them all together. They really have a ton of patterns that help you to memorize them. All right, so we're gonna do a few questions now that kind of relate to these rules. You're gonna notice there's a lot of USUB today, but we're also going to, once we get to the back page, really start comparing what questions work well for USUB and what questions work well for those ArcTrig questions. So the back page is really going to be about USUB versus ArcTrig. Are you ready? All right. First question. This is probably the easiest or maybe second easiest one. What do you think? What are we going to do? Okay. What's U? Okay. So what's DU? Sit. Do I have that 5 in my integral? No. So what should I do with it? Divide. So I've got 1/5 du is dx. All right. Let's substitute. You guys like taking that 1/5 out front?
Yeah.
Okay. Du has to go at the back. What will my new integrand look like? The stuff inside the integral. Cool. All right. This now is just one of the rules from the chart at the top. So I'm going to move down here because he's a pretty long integral. What was that guy? Regular natural log secant x plus tangent x. I have u's, so I'm going to do secant u plus tangent u plus c. I'm done, right? Oh, I got to plug u back in. Secant 5x minus 7 tangent 5x minus 7 plus c. Done. So, is it hard? Not in the process of doing the question, really. If I don't remember what the integral of secant is it hard? Yeah, it is, definitely, because there's no way I'm going to get there without knowing that. So if there was ever a time for flashcards, this section is really good. And most of these do not simplify at all. That's not going to do anything, so I would just leave it as is. All right, ready for another? Done 2 more. We get to take a break already. Wow. You're like, I would like a break now. Thoughts on the next one? Okay. What do you think U is? Okay. I know the derivative of 1 is 0. I did the hard part. So what's the derivative of 2z(x)? Mm-hmm. 6. Bottom right. Oh, you went to the back. Fancy. All right. Anyone freaking out right now or anyone feeling happy? I'm feeling relatively happy about it. So if I look, I've got 2 to the x dx here. I have an extra natural log of 2, but is that scary? Not really, because that's a number, right? Natural log of 2, this is a weird number. So I'm going to treat it just like I treated this 5 that I didn't need in this problem here. 1 over natural log of 2. Is it a weird number? Yeah, I don't care. A lot of these questions are going to be situations where everything kind of looks terrible, but it actually isn't that bad. All right. So let's substitute in. I'm going to stick my 1 over natural log of 2 out front and my du at the back. What will the 2 to the x over 1 plus 2 to the x dx, what will that all look like? 1 over u. What's missing? You mean I can't use 0 and 1? Ah, nice. We have to change our bounds. So talk with your neighbors. I'm going to give you about 30 seconds. I want you to tell me what new bounds should I have. If you are confused about what to do, maybe travel back to that guy. My air purifier hasn't been on. Do you know my new bounds? Oh, what are they? 3 and 2. Which one goes where? Yeah. All right. Can someone remind me, how did I get those? Can you just remind me? Okay. So if I do 1 plus 2 to the 0, that's 1 plus 1 or 2. If I plug in 1, that's 1 plus 2 to the first, 1 plus 2 or 3. I like that you guys put them in the same space as where I plugged it in is where it goes. All right. Reminder for you sub and changing bounds. The reason that I do that is once I get here, I never have to go back to the x's. So if you were one of those people that started plugging in your bounds and your numbers got really huge, really fast, remember you don't have to plug the x's back in. This is just the question I'm doing now. All right, this is about the 7th time today, and we've only done like 3 integrals, so that we are doing this integral right here. What function is going to pop up? Natural log. That was me doing Mia's bars. Absolute value of x. We are going to use the notation that says, hey, I integrated, but hey, I did not plug in my bounds yet. Speaking of plugging in bounds, which one goes in first? Explain. The one on the top. I'm only specific like that because it could be that 2 is on the top. We just want to make sure it's the one on the top. So thank you, Mason, for clarifying. I'm going to go ahead and just use parentheses to help. And I'm just going to stop. Yeah. So because we changed our bounds, these are values of u. So they can go direct. Oh, yes. I see what you mean. Thank you. Yes, thank you. Good question. I was going to go there. Do I still need the absolute values? I dropped them. Yeah, 3 and 2 are positive, so I know I can drop them. If you kept them on, you're just a little redundant, but that's fine. That's okay. Also, things about this answer. Let's say we were on multiple choice. This could be our answer here. I could also imagine them doing like natural log of 3 minus natural log of 2 all over natural log of 2, or maybe even like being a little clever like this, maybe. But this is just another reminder. Get where you're comfortable. That's probably there for me. And then start comparing to your answer choices. These are probably going to be multiple choice. So just get to where you're comfortable and then start comparing. Don't feel like you have to simplify all on your own by yourself. If this is a free response on my test, and this test is going to be all free responses pretty much, as long as you've plugged in your bounds, you're good. Yeah, that was me distributing. All right. Una más. I will tell you the next question we're going to do to get to break is the hardest question on the entire note. So let's get it done. And then we won't have to do anything as bad. I don't like when the air purifier turns on like full force. Makes you feel, and then it turns red and you're like, oh no. All right. So another part about these questions that we're doing in this unit is these all pretty much, once we get to kind of the harder ones, like this is definitely a hard one. This is probably like a bonus level question that we're about to do right here. You may not see the end from the beginning of the question. I know that is unnerving for a lot of people, but we're just gonna use our toolbox of tools and we're gonna hope for the best. So I'm just gonna scout for ideas. What do you think we should do? U sub? Okay, let's try. What would you set as U? You guys want the whole root? You want just 4? Okay. You could try both. So this is another unit where we're going to have to get comfortable with if our choice is wrong, that's okay. We can abandon it and try something else, and that's a feeling we're going to have to get okay with. So let's try this one. The reason I don't like using the whole root as it is one, that derivative would require a chain rule, and it would also produce another square root, which I don't have another one. So I'm going to try this one because I like the idea of a function inside another function. What is the derivative of 4 minus x squared, though? Okay. So I kind of like this, and I kind of don't. I kind of like this for like this part of this question. I'm not loving it for the +2 part. Does the +2 over that square root look like anything else? You were flipping to the front, Austin. What did you see? Did you see anything? Yeah. So Austin has the right idea. We are going to actually split this into 2 different questions. So first of all, we're going to split it into 2, and I'm going to show you what it's going to become immediately obvious. Maybe not immediately. Let me not use that word. It's going to become a little bit more obvious once we kind of pick apart this thing to show you why. So the reason this is kind of a bonus level question is I probably wouldn't give you one where you have to split it and it's like this crazy once we go through. But there's a lot of good stuff in this integral that we're going to see. What 2 colors do you think go well together? Purple. Well, no. Like this purple? Like a dark purple? Are you thinking like Barney? Does anyone even know who Barney is anymore? Okay. That green or the brighter one? Or like this one? Okay. All right, let's investigate why this is a really good idea. And if you're not seeing why this is a good idea yet, that's fine. We haven't done one like this yet, but I want to kind of sit down and really discuss it. So the purple integral, that is going to work super well with this u sub that we're doing, right? Because we got the x dx at the top. I can move this -2 over. That's super easy. And I'm going to be able to do that whole first integral with u sub. And that's actually the first thing we're going to do. We're going to separate this into like 2 completely separate problems. So that first one, we can do it. It's going to be a little gross, but we got it. Now, the 2 over square root of 4 minus x squared. I know what that one looks like because we did some rules on the front of the page. Can you flip over to the front and see if you can find any that look like a number over that square root? Arc sign. Everyone peek at that arc sign formula. I'm going to scroll up for a second. If you have a square root of a number minus x squared, but you're missing those x's on the top that you need for your u sub, actually, if you're missing the x's in general that you need for your u sub, the arc trig formulas are a really great place to go. So this second one is going to be with arc sine. So we have two, and actually the whole back page is kind of like this. We have two integrals that look very similar, but have very different methods of doing them. So let's do the u sub one first, since we're more comfortable with that. We're going to come back and we're going to do the green integral entirely separately, and our answer is going to just be those two things added together. So let's work with the substitution that we're doing. I liked what you guys chose for your u. The du is great. You guys cool with how I moved the -2 over? All right. So I'm going to keep my -1/2 out front, my du at the back. That's for all of x dx. So I'm left with like square root of u on the bottom of the fraction. Let me just write that as a step. A good kind of recommendation for a lot of this unit is like if you're getting confused, write more steps than you think you need to. Thinking about too many things at once can be overwhelming. I would love to rewrite this as u to a singular power. Anyone feeling like they know what that power will be? I like negative, and what kind? 1/2 for the square root. I like that. All right. Okay, that's now power rule. So I'm going to keep the -1/2 for a second. What will the new power on u be? All right, a lot of people are saying 1/2 with a question mark at the end. Does 1/2 make sense for right here? Yeah, what do I do to get new power? Add 1. All right, what number goes here? 2, how'd you get that? Is it the reciprocal of the old power or the new power? New one. So 2 works. 2 works. So we add 1 to the power. So -1/2 plus 1 is +1/2. And then we would like to divide by the new power. So we're dividing by 1/2. An easier way is to multiply by the reciprocal, which is 2. All right, let's just totally finish out this part of the question. Sorry, should have warned you. Can I cancel the 2's? All right, and then I'm going to change this back to a square root and plug in u. So I'm only going to do one more step. What was our u? 4 minus x squared? Cool. Now, if you didn't like the square root, you could keep it as everything in parentheses to the 1/2 power, by all means. So, good part, feel real confident about that one. Bad part, we're halfway done. Top to green. What? Yeah. All right. So essentially what I'm going to just do is I'm just going to roll and now do completely just the second half of this question. Now, would I give you one that's this hard on the test? Probably not. This is a little bit excessive for something that's not super important. But does it have good skills? Absolutely. Would I be very comfortable giving you just the purple or just the green one? Heck yeah. All right, so this one, what function did we say was going to pop out of the green one? Arc sine. So for arc sine, when we do that, really, I'm going to kind of skip the first step. When we do that, we're going to kind of have to figure out what u and what a are. So keep in mind for the formula, I'm going to scroll up for a second. That is going to be the square root of a squared minus u squared. So you're always looking, same thing with arctangent, you're always looking for kind of what thing squared would give me the thing I see in the problem. Let's see if you understood what I just said. What do you think either u or a are? You can tell me one or both. Beautiful. Okay. If your u has a derivative that is not just 1, you have to do a u sub. Since this one has a derivative that's just 1, we are good to roll. We will see one that needs a u sub later this note. So the arc sine, is that the one that had the 1 over a out front or no? No. So I'm going to go arc sine u over a, and now I'm going to put my plus c on. That one's actually already done, so I'm just going to keep pulling him down. Arc sine x over 2 arc sine x over 2. So this guy right here is my answer. Again, that is probably too much of a question to ask on a test. I'd be more so looking at one or the other, but I think it's got really good skills on both sides. And really cool with recognizing what part goes with what. What's up, Austin? What? Why would you just ignore him? Oh my gosh. You're so right. I missed it. That's why. This too should be right here. Thank you. So this 2 in the numerator, I was so excited about arcsine, I totally forgot. This 2 on the top needs to be somewhere. So Austin's right there, we should just kind of move it out front. That would work. Thank you for that. Yeah, Liza. How I got you an A? So you're going to look at these 2 things right here. In the, whoa, hello. In your arcsine kind of formula, when you're looking at it, it's a squared minus u squared, and arctangent is going to be very similar, where you're looking for what thing squared would give me 4. That's going to be your a. So 2 squared gives me 4. What thing squared would give me x squared? That's going to be x. Theoretically, yes. I forget why we choose the positive one. It probably has to do with the domain of your function. I'm trying to think. Maybe it just wants principal root. I'll look it up. Don't remember. All right, we feeling a break? All right, we got easy stuff. Easy. No. No, that was how much time? Yeah. You got 4. Take 4. What?
No one wants.
No. So you, since arcsine has a squared minus u squared, you're just working with the positive version. I don't remember why it wants the principal root. There's arctangent.
It started for them back in like December.
I actually, we did like a bunch
Dude,
of
that's
comparative
good, yeah,
stuff
when
and
you
we
learn
did
to
like
get
that. And I was like, I don't persuade it. I was like, that actually makes so much sense. It's like less breaks when I can feel it. Exactly. I think we we go to school
Less classes.
because like it used to be like
I mean, I love.
stuff, so they needed to
Yeah.
like that's not like people like this. It would be nice. I think college guys are like that longer break. Exactly. Yeah, that's what actually. It's just like memorize them. And you have some people get you a little more. You start really long and like
Because it would change
Here was the first trash. And it got like the trash and I had to get the we're just use on this. Everyone's debate. Dude, it's so many things. He had a parachute from the mountain. On the end, it's all it said 7 over some mountain. And he just decides to not go try and start. That's so cute. It's like, well, the best option here is to jump. And just straight up jumps out. Crashing the plane. You can make a little fella. So, not a small team, right? That's so everyone thinks that he decided to just crash his plane, flying over some mountain and jumping out instead of playing some song. And he just stalls all the time. Usually, you can know if that happens, just try to turn the key on. But this dude decided my best option is to take this convenient parachute, which I never traveled with, and jump out of the plane. That seems so sketchy. Probably video footage of him just purposely jumping out. He's not even trying to check the plane for anything else. This is what you're supposed to do. You're supposed to stay in that plane and your last option is just to jump out. It's like saying, oh, guys, I'm passing you. The engine failed. Oh, we're gonna jump out of the plane now. I like it. Passengers get off the plane. Maybe flight. You don't have parachutes.
All right, y'all ready? 3 more. I promise they're easier than the last one. All right. So first thing I want you to notice, and this is going to happen kind of a bit, is these questions all look kind of similar. They all have an x squared in the bottom. We've got different stuff on the top that's really going to determine how we're doing this question. So first question, we have a lot of stuff on top. What are your thoughts on how we could start with this question? I don't know how to factor this out. Good idea, but if there was a 2x up there, that'd be a great idea. All right, let's try some U sub. That's been working pretty well today. What do you think U should be? All right, that makes du what? 2x dx. So again, we're kind of in the situation where I like this for part of the top. I like it kind of for this middle term. So we could split it like we tried in the last problem, but I'm going to show you a way that's going to kind of work all of the time. Splitting it will work really well for this question, but I'm going to show you a way that will work all of the time. You're going to like it less, but it will work all of the time. What does a fraction bar mean? Divide. Remember long division? We're going to long divide. Give me a death glare right now. So let's do it together. He's so mad at me. All right. Anyone remember for long division what part goes on the inside? It's the top. And then just wait, we're going to long divide infinitely long polynomials later this year for a selected number of steps. It's going to be great. Okay, let's talk. Because they don't remember it. It'll be fine in 2 seconds. Because that's what a fraction bar means. So here, notice just that my du is like too small right now. I got too much stuff up here, particularly that x squared. Usually u sub is only going to work when the power on the bottom is smaller than the power on the top. So what I'm trying to do with long division is remove anything that's not kind of like in the remainder in the hopes that the remainder will be a nicer fraction. All right, let's remember how to long divide together. I promise it's not that hard, and this one literally has 1 step. What times x squared gives me x squared? Wow. All right, I am going to distribute 1 into x squared plus 1. So 1 times x squared is x squared. 1 times 1 is 1. I'm specifically writing that plus 1 under the other plus 1 because I want to combine, like, I don't want to try to combine 1 and x. All right, speaking of combining my terms, I'm going to do that down. What operation will I be using? You guys did learn something in Algebra 2. Shout out your Algebra 2 teacher. Nice. Kazmarsky? Miss Post. All right. Now, in this case, the x squareds cancel. If those do not cancel, you done something wrong. In this problem, the ones cancel. That won't always happen. That's from distributing in here. So that's the 1 times the 1 gives me the 1. So, yeah, 1 times x squared 1.
And then you put that on the.
I'm kind of aligning with the combined like terms. All right, when I subtract down, the only thing I'm left with is x. Can I do this process again? Can I do anything here times x squared to get me x that's not a fraction? No. So I'm actually done right now. Let's talk about what I'm done with the algebra part of this. Let's talk about what I just found. I'm going to leave some space above this, just if you're writing. I have 1, and then my remainder is x. That's still getting divided by the x squared plus 1. So my remainder goes there. The thing I'm dividing by is still dividing that x, but I kind of cleaned up the first part. Now, I don't know if anyone was listening to Jessica when she asked the question of like, how did I know to long divide? If I look at my du has a lower power in general than my u does. So what this has done for me is the remainder should have a smaller power than the thing I originally was dividing by. So this gives me kind of a smaller power in hopes that it will better match my du, which it does right now, right? I can divide by this too. That's an easy use of on that side. Also, I'm pretty confident I can integrate the number 1. Now, in this question, there's actually a much easier way to get to this solution. So I'm just going to show it to you because it's kind of elegant. If I split that guy, so I'm going to take all the stuff I just circled. And then all the stuff I didn't circle still being divided by the x squared plus 1. That's another way to get to that 1. That's kind of an elegant thing if you see it, but if you don't, sorry, that one lost. That's an elegant thing if you see it, but long division will work if you don't. So just putting that out there, that can happen. If you see it, great. If you don't, yeah, there's sometimes when you can like add and subtract something from the top of your fraction, but long division will always work if you need to get that power lower on the top. All right, let's go ahead and do some actual calculus now because we haven't really done any yet. The 1?
Yeah.
These guys are the same, so when I divide them.
Oh.
All right. I'm going to integrate 1 and get x. How should I do the second part of this integral? Not necessarily. If this had been like 2x here, 2. Or wait, that would be 2 here. It could be something different depending on how it works out. Or like a multiple. So if it had been like 2x squared plus 2, I could take that, factor out the 2, cancel. How would you do the second part of this integral? Yeah, we could use this u sub, right?
No one said over before.
What? That I can change the color of it?
You circled it. You did it on the other end.
Thanks. I try really hard to be impressive. I didn't know changing colors would do it. All right, I'm gonna move the 1/2 out front of my du. So I don't see the 2 from the 2x dx. So I'm gonna move it over just like we've been doing pretty much every problem. So here's another good instance. So I'm gonna substitute here. Probably about, I would say maybe a quarter of you are probably getting to the point where U sub may be getting a little bit boring. AKA, like, if I see this, some of you may be like, I see that that's just going to chuck a 1/2 out in front. Or like, especially something like maybe this one, the 5x minus 7, you might be like, that's going to chuck a 1/5 out in front. That is also something I can do in my head. So if you want to start doing some simpler U subs in your head, you are more than welcome. If the idea of doing U sub in your head freaks you out, don't worry. You don't have to. I'm just putting it out there that you can if you're starting to see some of them a little bit more quickly. What's this integrand going to turn into for this guy right here? Is it our favorite? Heck yeah, it's natural log again. I'm going to keep my 1/2 natural log. Let me actually rewrite that a little bit. Natural log, and my u was x squared plus 1. Oh, question. I changed my absolute value bars. I made them parentheses. Is that okay? Positive. X squared plus 1? Yeah, always positive. So yeah, it actually is fine. If you catch them on, also totally fine. All right. Last 2 questions. Kind of easy. Also, we got another Algebra 2 callback. Hopefully. I know anyone from post class, I know you know the method we're about to use next. But I don't know who in Algebra 2 teaches this anymore. Everyone should, but I don't think so. No one ever does, so I'll probably reteach you the whole thing. All right, let's talk next 2 questions. I'm gonna roll right through them. The last one's pretty easy, so we'll kind of do this one first. All right, what is your first idea? You've got this on your test. What's your first idea? You said? All right, let's try. What would you set as you? All right, let's try it. So what does that make du? That looks terrible. My numerator is effectively a 1. I am not creating a 2x minus 4 out of any of that. So this is one case where this idea is just not going to work. So if that's the case, especially if you need to create an x in your du that is not there, one thing you might want to think of, just like in this one where we needed an x but it wasn't there, is you want to start thinking arctrig. Now, since this one doesn't have a square root in the bottom, which arctrig are we thinking about? Arctangent. But that one looks like this. And it doesn't matter what order I do this in at the bottom. The idea is there's 2 things squared on the bottom. I currently have 3 things on the bottom of my fraction. I would like to turn this into 2 things. Kind of. We're going to try to factor a very specific way. I'm going to say some Algebra 2 words. You're probably going to either not recognize them or groan because you won't remember how to do it. And it's okay. They never remember. Does anyone remember how to complete the square? I'm a fortune teller. All right. So the goal of what I would like to do is I would like to complete the square. I'm going to show you how to do it. You may remember, you may not. This is not going to come up very often. I will tell you the notes check we're going to do today. The first problem looks exactly like this. I'm going to write things in a very specific place. X squared minus 4x plus 7. I like this problem because it gets across a very good mathematical idea of adding a very fancy form of 0. So I'm going to choose a number to add here that I will also subtract here. So I'm essentially going to add and subtract the same thing. Cora, do you remember how to find that number? Yes. So I'm going to take this middle number, in this case, -4. I'm going to divide it by 2, and I'm going to square it. Now, it's cool if you remember that. Let's figure out why that works the way it does. So what number is that? -4. Yeah, that should be +4, right? Let me write it in another color so we can see it clearly. So +4. So I'm not willy-nilly allowed to add 4 wherever I want. So I'm going to also subtract 4. So in essence, the two things I've put on the bottom there would add together to give me 0. So I haven't changed the value of anything. I'm just changing what it looks like. All right, let's go back to James's idea of factoring. Theoretically now, this part in parentheses should factor very nicely. What does that factor into? All right, x minus 2 squared. I have x minus 2 times x minus 2. So I've effectively created one of my things squared on the bottom. If you note Cora's idea of the b over 2, that over 2, that number before we squared it, is that number, that 2 there. All right, I'm going to combine the 7 and the 4 to get +3. All right. Now we look slightly more like this arctangent thing. So I want to see what is A, what is U. Remember, A is a number. So what is A, what is U? Close. Square root of 3. We want whatever squared is giving us 3. So square root of 3 is A. What is U? X minus 2. Does that have a derivative that's not just 1, or is it just 1? It's just 1, so no U sub needed. We should have a variable in our U, yeah. All right, arctangent, was that the one that had the 1 over A out front? Yep, so 1 over the square root of 3, arctangent, U over A, so x minus 2 over the square root of 3 plus C. Rationalizing is for dweebs, so we are done. All right, uno más, and then I will shut up, I promise. Thoughts? Typo? I needed the x. What did you say, James? Perfect squares on the bottom. Also, think if I U'd the bottom and I DU'd, I'd still be in this spot where I would need an x at the top. So I like what James is thinking for arctangent, essentially. Let's go ahead. I'm going to bring this 7 out front. And what are those two perfect squares? What squared gives me 25? So my A is going to be 5. What squared gives me 9x squared? A 3 and what else? An F. So U is 3x. Does that have a du that is not just 1? What's the derivative of 3x? 3. So here, I'm going to need to U sub this out. So I'm going to 1/3 this guy to the other side. And let's go ahead and substitute real quick. So that I didn't forget it again and have Austin task me, I put my 7 out front. I'm going to put my 1/3 with that to make it 7/3. I'm just going to keep 5 squared to hang out and U squared here. There, that looks a lot like arctangent. So remind me one last time, is arctangent the one with 1 over A out front? Okay, so 1/5 arctangent U over A, which was 5, plus C. I'm gonna go ahead and combo those fractions out front and just plug in my u again. So 7/15 arctangent u was 3x over 5 plus c. Parentheses if you want them. All right. Was this the most important day of BC calculus? No, by no means. The other methods that we're going to do for the rest of this chapter are probably a little bit more important. I would like to point out things that came up a lot today. Natural log, integrating into that, yes, that is something that you're going to have to be able to do. The prevalence of arctangent, that guy is going to come back when we do improper integrals and also later on because he does interesting things as you push him out to infinity and negative infinity. So he will come up again just because he's an interesting function. So hopefully integrating into that, not too terrible. What I would like to do now, I am going to give you a notes track. There are 4 questions on it though, so I am not giving you enough time to do it, and I recognize that. I'm going to collect it at the end of today, but I'm not going to grade it. I'll probably just check mark what's good, and we'll finish it at the beginning of next time. What will make me grade it right now, though, is if you don't do any of it. So you turn this back in blank, you're getting a 0, and you're not getting to do it again. So what? What? Oh, that is fine. You may go to the next. So what I want you to do is I want you to just try to get as much done as you can. I will say first one looks a lot like this. Second one looks a lot like this. Third one, don't do U sub, it's just a straight up rule. Last one, try it. All right, I'm going to give you different versions just so that you talk content. Do you want to try this? Oh, that was 3 problems then.
Should I take go to 2?
If you want, we definitely won't finish it today.
Okay.
Don't use it. Whatever you want. We're gonna finish at the beginning of next time. All right, so try these. We got a little under 13 minutes, like 12 minutes. If you got, I would make a good goal, like 2 of them done.
Yeah.
Again, 3, don't use that. 1.25. I don't try to use it.
What? Oh. Like, are you stupid? No.
I'm so excited for perfect.
Same.
Like algebra?
I actually do this.
You might like calculus.
Oh my God.
It was the first lesson I ever taught. Like at a. You all have different ones, but they look very similar.
Aww.
Are you gonna cheat off?
Me is gonna cheat off things.
Just check out what you're using. For that? The teachers have asked me, I was like, okay, you don't like it. Prove the wrong statement. You say you are very good at algebra. This might be your unit. It's a lot of algebra stuff.
That's what I remember. I do.
I can do like partial fractions. Okay, I can do them too.
I just have to remember how to do math.
I don't remember how to do
You got it by doing.
Divided by 2.
Sure, you're the only one that.
So 2 for me is the middle term divided by 2.
Oh, yeah, this is something.
missing in order. When the notes check.
One over you.
What's the?
So we took the middle one, we divided by 2 and squared it. If you're trying to start.
I'm so happy for you.
Oh.
Oh,
I see.
So much that affected. Huh?
I didn't get C. I have B. No, I didn't get 1. I didn't get 2.
I mean, what I heard is good divided by 2. That should be the number.
Oh.
Today is the lesson day.
Yeah.
It's actually a pretty new day.
Oh my god. This is.
You just look straight faced backwards too. I was trying to talk about this one.
It's like just normal thing. Oh no, whatever shall you do with clean water? Oh, you people are actually. Sometimes get really metallic. Oh, yours is metallic. Okay, never mind. That's right. That's what the water color.
Yeah, you can't simplify that there. No, because there's a difference.
But if I were to write X plus B button, would that be correct?
Yep, and I was just checking the axis of the.
But thirsty itself is not a word.
You're dying of thirst.
No.
Are you thirsty? You don't die of you're thirsty.
You can like.
Die of thirst.
I'm gonna say very sounds right.
Different words have different.
Exactly. You can't say thirst.
What's the word when the words have different
What is
forms?
the word?
Her.
That is nice. I made a squiggle on my ear.
She literally told me.
Oh, yeah.
I was strong desire. Oh, because we're I was strong desire. Third one, she said, "Do not even try to."
See, that's definitely what it is.
Thank you.
Minus 4. Oh, God, too small. But it's the you take the middle and you divide it by 2, and then you square it, and you add that. Add and subtract. Wait, I did that wrong. I had yeah, that's the order doesn't matter, but
The order doesn't matter, especially for our kids to be adding. So you just need to make sure that you're always choosing the new technology.
so even in this
And it's gonna be your number.
even in this one, people in reality.
Yeah, so our sign will always be in that order, because otherwise you're gonna be able to get off like that. But yeah, you want it that way.
So if I, like, that
So basically,
And you either break that out of the 17 or out of the 17.
So essentially, you're getting, when you're figuring out, when you're figuring out what is bottom of you, you're getting one stack. And technically that you're just gonna combine it and make it into one word on the bottom. And I do other side. The other side is we're gonna take and take back. The other side is we're just get that.
So that comes in the two.
Right. And also, the UA is not.
This one is actually just.
So it's not like adding 90%.
Yeah. All right, I'm gonna talk to you in approximately 1 minute.
that's supposed to be a.
I'm gonna let you introduce that one. I will look at your rules. Hello.
Ah.
So, this is center number, and divide it by 2, and square it. We've got somebody else's line. And then square it, and then from there, whatever you get.
Usually I'll write
What about
the
with
the vertical bar.
So you add it in here, and then bracket it outside. And you get that outside number by doing x squared minus 4x.
It looks like you're trying to do this.
And then this number is clear out my binder. And then you
Well, I
subtract
prefer it
here.
anyway. Not enough time.
That's fine. All right, we have about 1.5 minutes left, so I want you to pause wherever you're at. I don't really want you working on this at home. I'd like you to work on it just for your next class. So if you're done, absolutely fantastic, wonderful. I'll check off whichever ones are right. If you're not done, I would like the feedback of how things went today. So if you could turn that in, that would be great. Also, if you want, before you start moving, the new problem sets are blue. They are here. If you would like to pick one up, you can do, I think, the entire first page already. Theoretically, actually through number 5, you can do if you want to start working. So I grab one before you leave. This one is easier than that because we actually have this on the top. So it's a little bit easier than one.
Does this go here?
Yes.
But that would be the right start if I want to do it.
The use of would, yes, be the right step.
Okay. So I'm just trying to figure out.
You're good.
And I'm looking through the
Thank
formula
you.
to do this. And I'm like,
Yeah, there's a lot of choices in this one. Thank you, Asia.
Right here.
Yep, that works. Thank you, Liza. All right, y'all. If you want dates, I'll put them up on the board, but I would write them in pencil. You know, January, it snows sometimes. Thank you for your hard work today. You guys will enjoy next time. Make sure I get your notes done before you leave. It does not have to be done.
I can't believe he seriously just jumped up.
Yeah, we don't have.
So dumb.
oh, hey, oh, you seen the video?
Yeah, I was watching that.
Yes.
Dude, he didn't know you were required by law to keep
trying.
So the whole thing has to be done by a week from tomorrow. So when you get the corrections done, I just have to see them, absorb them, make sure, if there's any things I have to talk to you about, and then, you'll put those in.
Okay, so you want it to be done by the end of the week.
The whole process. Yep,
Okay, so if you last.
yeah, that'd be nice. Exactly, yeah. So we'll have the rest of the notes checked and pass the problem set. Depends on who gets noted. Usually, if it's like very small numbers, I write around the green already. So if it's like very small numbers, I would make sure all the note checks are corrected. That will definitely convince me to. No, I don't. You're good.
Whenever you're at.
Why do you know if you're really not using that well, so I totally get that.
Like, well, it's kind of like when I say exactly.
Yep, probably right. Exactly. All right.
If it's a snow day, I'll email you and then we can.
Yes,
maybe set up-
that sounds great.
Maybe another